Friends, this is one of the most important lecture. On the basis of this lecture, our next all the lectures are interrelated. So, and it is also a bit philosophical also. It's based logical and also some understanding of the nature of statistics and what is the relation between statistics and probability. So these are the things has to be discussed here. Next. We generally have encountered these three words: possible, plausible, and probable. Sometimes we intermixing the values, the meaning of these three. So what is that? What is possible? What is plausible? And what is probable? That has to be understood first in order to venture in the probability and statistics. Next. Possibility is capability of happening, existing, or being true without contradicting proven facts. So if you flipping the coin, you will get either head or tail. It is a proven facts. And the laws are there, probability laws are there, and some circumstances evidence is happening. A tsunami, then your case of earthquake, flood. So you know some correlation here, some circumstances, this will be happened. Plausible, seemingly or apparently valid, likely or acceptable, credible. So pole forecasting is a plausible phenomena, actually apparently valid. It may be likely or acceptable, but it has to be credible. Or there is a water in the Jupiter. Some kind of a valid information and some correlation or possibility of the existing laws we are predicting. May not be correct, but it is there. We are predicting the things. Probable is that likely to happen or to be true but uncertain. That means if you flipping the coin, it will have a head or tail, but uncertain at what will come, head or tail. Or rolling the dice, you have a 6 events, 6 outcomes, 1, 2, 3, 4, 5, 6. This will be happen, any of them, but it is uncertain which will come, 3 or 4 or 5. And that is the game of excitement actually. In the cricket also, you will know that this is the, if the ball is coming, there is a possibility of 6 runs actually. So this is the probable business, or the man maybe 0 and go out. And plausibility is that which we are telling the apparently that, okay, if this situation arises, Tendulkar will make a century or Virat Kohli make a century. It is a plausibility. Apparently valid, likely or acceptable, credible, but you are predicting apparently, not sure what will happen. And plausible and probable is within the possible. Then not so. Next. So probability and plausibility is within the possibility. Two things. One is that likely to happen, but uncertainty. It apparently happen. It may happen. It may not be also happen. Apparently happen. But possibility is both. The plausibility and probability. Next. Now, we are basically in pollution control manager, and or you are going for an inspection. So what is the fault finding? One of the thing is the fault finding of the installations. What is the probability of exceedance ambient water air quality performance? This is one of the things. That what is the probability out of 365 days, if I take the air samples, what is the probability of getting severe? What is the probability of getting bad? What is the probability is getting good? So this is the question actually. Then the forecasting. Probability of rare event and near miss situation. Rare event is that earthquake, tsunami, and a near miss situation, or in the accidents like Bhopal. It's a rare event, but what is the probability of happening so? And what is the near miss situation? That means it would have been happen for a chance it didn't happen. Just on the mouth of the happening, it didn't happen. It is called a near miss situation. Generally, good factory, when they are taking the kind of a safety evaluation, they count the things of near miss situation, and the factory people have been trained. They identify this is a near miss situation and they report it. And the probability statistician or the man who is taking the safety, he calculated if the 3 near miss situation is happened, they have called one situation and they rectify themselves accordingly. Then the question is that we have to distribution this uncertainty, probability distribution, and find out the reliability. Very, very important phenomena of the statistics, understanding of the statistics. Next. 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 Now, something has to be understood. What is the random phenomenon? A happening with 2 or more outcomes, if the outcomes are associated with uncertainty. It's a tossing of a coin, 2 outcomes. Rolling of the dice is another thing. The 6 outcome is there, and these outcomes are associated with uncertainty. This happening is called a random phenomenon. That means if there are 2 or more outcomes in a happening, if the outcomes are associated with uncertainty, this happening is called the random phenomenon. Next. Now, better to understand this random phenomena, how to find the probability of the random phenomena. Actually, the probability calculus, in middle time of the history in Europe, it was being stopped by the church. Church was not favoring the development of the probability, because probability is developed with the gambling phenomenon. And so these statistics was later developed in compared to other part of mathematics, because it is associated with the gambling. And the gambling is a fun also, but it has an addiction also. And the problem is that any game has some kind of uncertainty. Uncertainty is not there, game is not interesting. Say cricket, this T20 game is so uncertain. It's full of probability actually, full of probability. What is prediction is a very, very difficult phenomenon sometimes. More difficulty is the uncertainty, more interesting is the game. That is associated with the gambling. When cricket outside the field, there is a gamblers are sitting, right? They are telling, making century by Virat Kohli. They will give, say out of 10, they are giving 8 points. Making century by Bumrah, it is 10. Sorry, Virat Kohli will be 2 or 3 because it has a certainty. Bumrah will make a century, it will not a certainty. So they will give it 10. This is the way gambler is playing the game. Now the question is that this playing of gambling in the middle time of the Euro, middle time, historical time of the Euro, that was there. They are the nobleman, the family of the noble persons, when a king or minister's friend, they are also associated with the gambling. They want to earn money out of it. And what they are doing, they are hiring good mathematicians to predict the things. Even today, share market forecasting is also hired by the good mathematicians because they are forecasting the share market, which is a very uncertain game, very, very uncertain game. Now, one phenomena they have observed, why 7 comes more than 6? That means if you playing the pair of dices, you will find 7 is coming maximum. What is the thing? Why it is happening so? So they are hired, the French people are hired Pascal. Pascal is a great mathematician, very young and very energetic. How Pascal deduced the phenomena why 7 comes maximum times. I will show you and how the calculus has developed like that. Next. What Pascal did, very interesting. Pascal did, there are 2 dice they are playing. What is the possibility? He saw if the die playing and both the die is 1, sum is 2, it is appearing at only 1 die. Same is happening with 12, 6 and 6. It is happening 12 times, 1 time. But in the case of 3, you will find, you scan the things, it is coming 2 times. 2, 1, that first die is 1, second die is 2. And the second 3 is the second die is 2, first die is 1. So he is going and he found that he found a table. Next. He found a table, sum is 2, outcome is only 1. It is a rare event. Then 3 is coming 2 times. 4 is coming, 3 is coming, 4 is coming 3 times. The outcome is 3. 5, the outcome is 4. 6, the outcome is 5. 7 is maximum outcome is 6. 7 is a lot of combination. 3 plus 4, 4 plus 3, 5 plus 2, 2 plus 5, 6, 1, 1, 6, like 3 and 3. So, 3 and 4. So this is a 7 times this kind of, this outcome is 6. So 7 times 6 is coming. That was the discovery of the Pascal. And he made a bar diagram and he saw these things are coming. So brilliantly it is coming, outcome and sum. Brilliantly it is coming. And it see that most frequency the 7 is coming. So if somebody bet on 7, so it's a bet. Somebody say 4, somebody says 7. His chance of getting 7 is more higher than other things. So if you want to play 5 and 6, so 6, 7, 8 is your number and your outcome is 5, 6, 5. It's the most probable area, right? And here you will get. Same thing is coming is roulette. That is moving like this. So it is moving in a circle and the number is coming 1, 2, 3, 4, 5, 6. So number is coming. And if you go on this, the making is such a fashion that last like just like your watch, and these things are moving, indices is moving, index is moving. And if you observe carefully, you will find some particular number is coming maximum time. Once I have done, once I did it in Nehru Place. So पहले दिन first day I got a lot of money actually. After observation I concluded. Second day I did the game and I got the money. Third day I got the money. Fourth day I went, that shopkeeper told me, sir, I am a poor man, you don't come. So he understood, I understood where it to play. Casino also like that. If you go on giving the coins and giving coins, and if you find that 10 people after playing, the 11 people is gaining maximum, 11 or 12 people. So that is the way the game has to be played actually. The unfortunate part is that if the dice, one dice is giving a little bit weight more, then this, it is not playing properly. That was done by Shakuni in the game of Maharashtra, Mahabharata. So Dhritarashtra, your Yudhishthir was defeated because it's so cheating. Next. So in order to close down this cheating, it was happened in Europe also. It has happened in Mahabharata time also. So in order to close down the cheating, some rule has been developed. Next. Events A1, A2 and are called exclusive. If they cover all possible outcomes, that it is impossible, none of them come. So in case of dice, 6 possible outcome is there. And it is impossible, nothing is coming. Something will come. Like that in coin, either head or tail, nothing is there. And it will be equally likely. That means every outcome must be equally likely. It was not happened in the case of Mahabharata. That Shakuni played the game. He made some tricks in the dice, and that is why that true man, his honest man, Yudhishthir was defeated. So it was that exclusive event, equally likely. It will be random phenomena. Next. 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 So all these 3 properties that I have told it will equally likely, exhaustive, and random phenomena. Then this is called as a classical model, and the outcome are termed as chances. Then probability is the ratio of the number of chance favorable, that is M, divided by total numbers. Say case of head and tail, 2 chances are there. So N is 2, and you are preferring head. So 1 by 2 is the half. That is the case. And tail is also equally likely, half. So half plus half is equal to 1. Same is happening in the dice. There are 6 outcomes. So number of chances is 6. And 1 is for 1 by 6, 2 is for 1 by 6. One time they will come, 1 by 6. Possibility is that. So 6, you add it, it is 6 by 6, it is 1. So this is the definition of probability for a classical model. And what is the classical model? It must be random phenomena. It must be exhaustive, exclusive events and exhaustive events. And it is a equally likely. These 3 phenomena must be there. Then we can go with the classical model. But the nature, excuse me, but the nature never follows this classical model. How it will go, we will do little later. Try to understand the some of the other theoretical framework of probability, that is addition and multiplication. Next, two things you have to remember all the time. Variables. It is a general properties. The color, size, these are the general properties. And if you specific forms of the variables is called the values. That means color is red, green, values. Size, large and small. This is there. Variables, water quality parameters. Variables, values are, okay, variables, they are also trading, DO, BOD, COD also causing as variables also. Values is that high, low, medium, and these are the called values. Size is large and small. Right, next. Now, I am going for a addition model. I have a 4 types of marbles available with me. One is a red marble, that is 100, 50, 30 and 20. That means 200 marbles are there. Out of them, 50% are red actually. So green is 1/4, then 30, then 20. And there are 2 types of size. Red has a 50 large and 50 small. Green has a 25 large and 25 small. And blue has a 15 large and 15 small. It is a large, not small over. And it is a 10 large and 10 small. So this you corrected, please. 15L and 15 small and 10L and 10 small. This is the size. So right side is a small and left side is a large. Now we have a 50% red, large size, and 50% non-red is a large size. Next. Now we are telling the value, right? One parameter we are taking value with the one parameter of the variable color with the 2 values red and green. So find the probability of getting red. So our classical model is saying total marble is 200 and out of 200, 100 is red. It is 0.5. So finding probability of getting green, 50 is the favorable, that is green marbles, and 200 is the total marble, is 0.25. So simple is that either red or green. I have taken the 2 sets now. Either red or greens is equal to 0.5 plus 0.25 is 0.75. This is the addition rule. If A and B are exclusive values of random variable. Exclusive means, you see this cursor is lying in the red and if cursor is come down, there is a set, R and green. So there is no overlapping. Red is red and green is green. So the shading area that is simultaneously red and green is not coming. So shading area we are telling is a null now. So it is exclusive value, only red and opposite green. Nothing more than that. There is no in between there. Either it will be red or it will be green. That is either it will be head or it will be tail. That is half plus half probability is 1. Right? Next. Now, what happens when if red large balls are there? If I say either red or large, so large red ball is 100 marble and 200 total marble, whereas large marble is 100 by 200. So 0.5 plus 0.5 is equal to 1. It's wrong. That means all the balls are red and large. No, there are a lot of balls are there. Red ball is there, green ball is there, blue ball is there, yellow ball is there, small ball, small and large size is there. So here it is that probability is 1 means 1. So what is going wrong there? What is wrong here is that we are searching red and large, not or large. So and is the overlapping. Within the red ball, there are large ball. That we are searching. It must be a red ball. At the same time, it is a large ball. Simultaneous occurrence. In that case, it will be multiplication. 0.5 into 0.5 is 0.25. This is the same answer. Red and small, the same thing. Small is 50%. So out of 100, 200, out into 100 by 200 is 0.5 into 0.5, 0.25. So multiplication rule is that when AND is coming, red and large. The red ball at a simultaneous is a large ball. Red ball as a simultaneous is a small ball. That is the case of the multiplication. So variables, two variables intersection here. The variables color and size intersected. Whereas in addition rule, variables color has been only going one variable defined with the color. That one variable is there, then it is addition. If there is two variables are there, then intersection is there. Intersection means it is a multiplication. Next. Now this game is correlation problem. So far it is a non-correlated. Now you see the second thing is there. Red ball is 100 and size is 80 large ball and 20 small ball. And here is the 50 is the green ball, 10 large ball, 40 small ball. Blue is 30 balls. Out of that, 5 is large, 25 is small. Yellow is 20, 5 large and 15 small. So non-red is the non-red ball. The large is 10 plus 5 plus 5. That is 20% out of 100. Whereas red ball, 80% is the large ball. So this is the game, right? Next. Model 2 of the multiplication rule is that R and large, that is red and large, PR into PL, it is coming 0.25. But proportionality is telling 80 by 200 is 0.4. Here we are taking a correlation. There it was not a correlation. That is, it is a large red ball. It is a correlation. One stage select the color red and second stage large among the red. So PR into PL by R, L by R, that is large among the red. So 100 into 200, 80 into 100, so correction is 0.40. That is proportionality. That means here red large red, where R large and the red. That is red ball and the large ball. All the red ball and the large ball, large red, that is the intersection of the things. Here it is 0.40, right? Next. So it is there. If A or B are two values of random variables, A or B, and two values of random variables, large and green, red and green, So PA plus PB minus PA and B. So in case of this 0.5 plus 0.5 PL and RAR, PL plus PR minus PL and RAR is 0.5 plus 0.5 minus 0.25. That is the where the cursor is lying. That is 0.25. That is the PA and B has to be eliminated. Okay, that is 0.75. Next. So here P, R and L. So PR and PL by R. This is the things. So it is there 0.5 in 0.8, 0.4. So values of two random variables, then P A and B is PA into PB by A. That is your general multiplication. If it is not correlated, it is PBIA is equal to B, PB. That is PA into PB. It is not correlated, right? You understand these problems now. Thank you. Next. Now I am giving you some example. Now it was happened that the court, Supreme Court is asking central board shall utilize its zonal office or the inspectors, and the selection of the things will be on the basis of a at random phenomenon. And the people will be say you go to that place. Suppose people will say from you Calcutta you go to Jharkhand, Jamshedpur, and then they are telling you enter in that factory. It is happening in Gujarat. There are so many factories in one place. So you tell you go to Ankleshwar and choose this factory A. There are 1,000 factories out there. So how will the choice will come? Choice will come that we go for the random phenomena, and this will come in the computer will find out the random phenomenon and say 4 number industry, and port number 4 is this industry. So if the number 4 industry is inspected, next time 4 will be eliminated. So now out of 100, number 4 is eliminated. Now 99 industry is left. So next time 99 will be rolling, and we got a 64. Like that way you have to prefer. So I am giving a small way how the things have been come. A region contains 8 factories, suppose 5 being textile and 3 being sugar factory. If an inspector not being biased prefers to choose 2 factories at random for inspection purposes, what is the probability that the inspector will get 1/2 of each other? How to approach? Absolutely non-biased fellow. He have a 5 textile and 3 being sugar factory. And he has to choose at random, right? The paper where text, so 5 paper has been written, 5 text T1, T2, T3, T4, 45, and sugar is S1, S2, S3. And as it just drum it and throw it, then people will find out that say he got first is the textile industry, and second is the sugar industry. Second time. Let me see. Next. First factory chosen will be either from textile or sugar. Now, first factory is textile. There are 5 favorable, 5 textile industries there. Out of total 8, 5 textile plus 3 sugar. So 5 by 8 is the first time. Now second we have to choose. In second, we have 7 factories. out of which 4 is textile and 3 is sugar. Hence, the probability of choosing a sugar factory is 3 by 7. So thus the probability of choosing sugar factory after textile is 5 by 8 into 3 by 7 is 15 by 36. So you see total chances from 8 it has come to 7 once one time is gone. Next. You must say, sir, what you gentlemen, you are telling the things I agree with you. But the case that this fellow can get a first is a sugar factory and second is a textile. Okay. Then 3 by 8 is a sugar and 5 by 7. Then again 15 by 56. So choosing either textile or sugar is 15 by 36 plus 15 by 36. It is 0.535. This is the simple way I am planning that how the additional rule or multiplication rule. First, it is a multiplication, simultaneous operation, and second is the addition. So how the addition rule and multiplication rule is helping us to decide these things. Next. Now, fault finding and binomial distribution. Now, slowly we are moving. Objective of inspection and pollution control to infer simple thing either compliance or non-compliance. If comply is termed as okay and non-compliance comes as NC. It may be one parameter BOD or particulate emission, one parameter we are taking. Case by case study with respect to probability calculus is briefed. Very interesting. Please concentrate. Next. Probability of P of NC non-compliance is 0.1. Then the probability of Q being okay, that is compliance is 0.9. So probability is either if okay or NC is P plus Q is equal to 1. Now you are entering and getting the phenomena. Next. Let two industries is chosen. How it can be done. First industry has a either okay, that is compliance, or NC is non-compliance. Good. Second industry is also okay and non-compliance, okay and non-compliance. If 4 outcomes are coming, 2 are okay, 1 okay, 1 NC. That means 1 okay, compliance, 1 non-compliance. In the second is that first is non-compliance and okay, NC okay, and 2 industries are non-compliance. This is happening. So we have a 4 outcome. So 1 is okay plus okay, that means Q square, right? And NC is P square. PQ, P and Q are P and Q, right? So 4 phenomena, PQ and QP. This is the 4 phenomena. Next. So probability of both non-compliances P equal to into P is equal to P square. That is 0.1 square equal to 0.01. Both are non-compliance. So probability is 0.1. Probability of both compliance, not non-compliance. This non will go from here as a typing mistake. So Q plus into Q equal to Q square. So 0.9 square is 0.81. So either compliance or non-compliance, P square plus Q square. It is a Q square. P square plus Q square means P square plus Q square. C is 0.82. The probability of either OK or NC, 1 minus 0.82 is 0.18. That is PQ plus QP. That is the probability of either OK or NC. So 0.1 into 0.9 plus 0.9 into 0.1 is equal to 0.09. So probability is P square plus 2PQ plus QA square. If two factories are there, this situation is coming, two factories are there, right? So this situation, both non-compliance, P square, both compliance, QA square, one compliance and one non-compliance is 2PQ. This is the situation. Next. I will go for three industries. Good. 3 NC, NC into NC into NC is PQ. That is 3 are non-compliance. So it is a PQ. 3 are compliance. It is a QQ. But 2 non-compliance, that is 3P square Q. 2 non-compliance, 1 OK. And 1 non-compliance, 2 OK. That is 2 compliances, 1 non-compliances. So P, 3 PQ square. So this is the logic. Next. Now, 4 industries are there. With say, what is situation? 4 NC have a probability, P4, 0.014. That is 0.001. And 0 is 0 compliance. When all are 0 non-compliance, means everybody is compliant. The probability is 0.9 to the power 4 is 0.6561. Last. Then 3 non-compliance, 1 compliance. This 0.0036. 2 non-compliance, 6 P square QA square, 0.0486. 1 non-compliance, 0.2916. So this is coming only P plus Q4. This is the expansion of the binomial. Expansion is like this. And Pascal give a very beautiful things which I will discuss later. Next. Next. Now you have a 0, 1, 2, 3, 4. 5 system has come, and I will give you how it is coming. Next. So percentage is that maximum 0 means number of non-compliance 0. Maximum, that is mostly compliant. But 9, 4, 0.9 into 0.9 into 0.9, that is there. 1 is this. It is around 25%. Then 3, 2, 3, and 4. This 4 is non-compliance is a rare phenomenon. 0.0001. That is a rare phenomenon. Only a small line is coming. So this is the binomial distribution is coming. Next. Pascal say, how you will say this thing? Pascal make a very simple triangle actually. Suppose one die is playing, 2 event, right? Head and tail. 2 die is filling. 1, 2, 1, 4 event, 1, 4 outcome, 1, 1, 1 and 1. So 1, 1 is 2 and another 1 is 1. Now 1, 2, 3, 2, 1, 3. 1, 1 is there. It is a 3 times. 8 outcome. 4 times 16 outcome. 5 times 32 outcome. 6 times 64 outcome. So this is the way the Pascal's phenomena is coming. Pascal's triangle circle. Next. Now we have to say, well, you have given the distribution. What is the expectation? Expectation means coming as mean actually. So we have seen 0 point plus 0.1 to the power 4, that is terms of expansion. So it is coming this. Now we are inspecting 10,000 industries with 4 parameters of as compliance or non-compliance, right? If 4 parameters are compliance and non-compliance, then what will be happen? We'll multiply that outcome into 10,000 industries. 4 parameters in BOD, COD, PH, say TDS, total dissolved solid. So 0 non-compliance is 6561. That means 6561 industries are doing very good. So 2916 is only 1 parameter non-compliance. Mostly case it is COD. 2 parameter COD and TDS is 486. 3 parameter that BOD, COD, TDS 36. And 4 is non-compliance. Only 1 industry is there. With 10,000 industries. This statistics you have corrected. Next. So what is this? Frequency of 0 non-compliance. 6561 into 0. 1 non-compliance. 2916. 2 non-compliance. 4186. 3 into 336. 1 into 4. Simple things. It is coming 0.4. If you see n and probability of non-compliance 0.1, 4 into 0.01 is 0.4. The same way you can calculate the variance, it is coming 0.36. So this NPQ. So this is the binomial distribution, their mean and their standard deviation. So you can calculate like this. Next. Now we go for a very common phenomena is the normal distribution. Next, in order to understand the normal distribution, you have to find out population is a larger body of collection items. We have to understand what is population, what is sample, and what is sampling. Population is a very large body of collection. Say population of Delhi, it's around 11 million, 10 million, that is like this. Now you are going for an opinion poll, which is a very common sampling system in India, and all people you understand and enjoy it. 80% of them are not coming true. 20% out of 20%, 1 or 2 is very true. It depends that how you are taking the sample. So if you are taking a large sample, say 10 million people, at least you have taken 10,000 samples and see the opinion poll. Kejriwal jitega, whether Kejriwal will win or Modi ji will win. So who will win? That is the question. And they are coming. Or in the case of Bihar election is going on last now, RJD and Mahagandhan both on the NDA. So yeah, people are collecting samples and say few questions they are asking, and that is their opinion. On the basis of opinion, they go for a frequency. How much people are supporting Nitish Kumar ji? How much people supporting the Mahagandhan both? So that was the thing they are collecting actually information and frequency they are telling. And accordingly, they are predicting that out of 10,000 proportion, and they predicting for the probability calculus. Now, if it is successful, if it is they collect the samples from such a way that every element of the collection has the same chance being selected. That means he may be a literate fellow, he may be an educated fellow, he may be illiterate fellow, he may be elite class, he may be aristocrat, he may be middle class, he may be poor man, and there is a caste also. So all things has to be chosen that every element has the chances of coming as a sampling system, sampling collection. And that is the success of the polling tool. So more the samples, more the correct things. How it comes? I will give you the examples. Next. So statistics is an area of science concerned with extraction of information from numerical data. So you are inferring the, suppose, measurement of the rainfalls or the water quality parameters, and use in making inferences about a population. You are taking one sample in a day for a 1 month, in a week, and then telling this is the air quality of Delhi, of that week. And if you real time, every time you are taking, that is every minutes, you are predicting more correct. That is that the inferences. Objective of statistics is to make inference, prediction and decisions about a population based upon information contained in the samples. If you are taking too much samples, you have to cost. And if you are taking less sample, you have the chance to be error. That optimization is necessary. Probability is the unknown population, known population, unknown sample. Probability is a logic. It's a mathematical reasoning, logic. And it is a mathematical truth, logical truth. Statistics, the population is unknown. With a known sample, you are predicting unknown population. Statistics is based on observation. It has an error. It has an uncertainty. So any prediction has an uncertainty. There will rainfall tomorrow in India. There is a chance. There is a rainfall tomorrow in Delhi. There is a chance is less. There is a rainfall tomorrow at the CAC office. Its chance is very less. If you are going for a precision information. So that is why there is a rainfall in Delhi. One part of Delhi there is a rain, one part is dry. You cannot blame the meteorology. Delhi is not a meteorological district, a meteorological area. Northern India, Indo-Gangetic plain, like where meteorological area will be bigger. And the meteorological condition, the Himalayan, trans-Himalayan barrier, geological condition, that has to be considered for meteorological prediction. So that's why prediction from the statistics needs the sampling and the character of the samples. And then apply the mathematical rule to reach the probability, and there must be an error. Somebody say analytical chemistry, there is an error. All the time there is an error. That is the thing actually. Next. Now the question, what I am collecting in the statistics, that is frequency, is it probability? when frequency tends towards probability. That was the question. Now, if a coin is flipped, there is a head or tail. Or say if there is a child bar, either male or female. Mathematical probability head child bar is male and female, 50-50. It is not happening. Next. So now, flipping of a pair of coin, two heads, head and head, head and tail and head, and tail. This is the case of a flipping of a pair of coin. Four outcomes are there. Next. So 1/4 head or tail or head is half, and 1/4 is the two tail. This is the graph. Coin is flipped, or two coin is flipped in one times, or one coin is flipped in two times. Next. 8 flips, 16 flips, 32 flips, 64 flips. Then next 128 flips. This small interval is crushed. It is coming a beautiful car. And the car is calling the bell-shaped car. Because if you go to the church, there is a bell. Church bell is looking like this. Next. And this is the car they are calling normal distribution. Gauss, one mathematician, he made the formula of this car. Y equal to x minus mu. Mu is the mean and x is the position. Divided by 2 sigma square. Sigma is a measurement of this plate. That means standard deviation. E scale is taken, natural logarithm scale, and 1 by root over 2 pi is been added to get the equations 1. That means the area of the car must be 1. That is the basis of this normal distribution. Next. Y is the height of the car. At any point you see, the height of the car means the frequency. And that frequency, more samples are there. It is densely coming as a probability density. So standard deviation population mean, right, is sigma, Napier scheme, and pi is 1 by root over 2 pi is a constant. We have taken this constant as a 1. Actually. We have taken in the car because to make it 1. Now the question is that frequency tends towards probability. That is, what is observations? Is coming of a mathematical truth, and observational truth is close when your number of samples is high. It is very beautiful, it is coming. Whether is an industry is performing well with respect to emission, real-time emission analysis, some uncertainty must be there, and that uncertainty has to be calculated properly, and then say, okay, 200 is your limit, 200 plus minus 15 is acceptable, and with this amount of data observation is there, right? Then that phenomena of the emission, real-time emission analysis can be taken legal. It has to be observed very carefully. Now x minus x bar, where sample value is small, then it is coming, they calculate as a t, x minus x bar divided by t, so t squared 2, equation is simpler. and the area under this curve is 1. Now, next. Look, you have a same mean but different spread. Same mean with a small spread. Suppose one factory is generating wastewater of a BOD value with a mean with a less standard deviation. Then what is happening? That means it is a consistent data. Or more, that means the consisting is not there. Unconsistent, more spread is there. It is inconsistent. If it is generating consisting data before treatment, design of the effluent treatment plant will be easy. Design of air pollution control devices will be easy, because you know the design parameter things, and it is a fluctuating generation. That means if somebody factory has a more spread, he has to control his production system, then he can be APTC, will be successful. Next. Define mean with the same standard deviation. Both have the same type of consistency, but mean is different. Right side curve, I think reddish curve, the mean is a higher than the bluish curve. So this is the thing. Different mean but the same type of standard deviation. This is the question of the character of this curve. So you, from the character of the curve, you can tell many things actually. Next. Now with 1 sigma is a 68%. Mean plus 1 sigma. Mean plus 1 standard deviation. If you cut this entire curve is pieces with 3 sigma in right side, 3 sigma in the left side, that is range is taken by 6 sigma. 1 by 6, right? So 6 sigma is equal to 1/6 is into the range is equal to 1 standard deviation, right? Range, total range divided by 1/6 is equal to standard deviation. This is a thumb rule for normally distributed data, not skewed data or things. So 2 sigma is a 95% coverage, and 3 sigma is 99.7% area is covered. So more you are spreading, more data you are accepting. That is the things. Next. Now your TDS, what is happening? TDS frequency distribution in T scales. With that we want to go. So 145 to 153, where the maximum frequency is coming, we called it 0, because here is the mean lies. So now we take 10, 20, 30. That means 10 is the standard deviation we have considered. Accordingly, 136 to 144, we call it -10. 154 to 162, we call it 10. So this is the way we have frequency distribution we have been taught. Next. It is called standardization of the curve. If the mean value is taken 0, then it is a standardization of the curve. So now the standardization curve, you get the probability. So if it is a point 0 is the t value, then probability is 0.5. That is either this or this. So probability 0.75 is the t value, then 0.227 is the probability. Next. What is the probability that the TDS value fall between 154.6 minus and 147.6? So T value is 154.6 minus 147.6 divide by the standard deviation 10. That is coming 0.7. And 0.7 you are getting the probabilities 227. That is, if you are taking 1000 samples, 227 sample will be in 154.6 to 147.6. It's coming. If you have a huge data, then this value you can predict. Particularly ambient air quality, ambient water quality, and air quality, noise quality, you can do these things. Same is the 148.6, 138.6. So 148.6 minus 138.6 divided by 10. So 10 by 10 is 1.159. You see the t values of 1.59. What is the t value of 1? It is 0.159, and that is why it is the 159 sample out of 1000. It is coming like this. So this is the way we are getting frequency curve to probability. In factories, failure of the pump, you have a huge database. If you take the database, you will predict the probability that this is the failure of the pumps. This is the why the European, they are data biased. They make a prediction. They say that after 10 years, this pump will not run. They reject it. They know the failure frequency will be higher. So that is why their decision taking coming very correct. Prediction of the, now India has improved meteorology very much. I tell you very much. Last 10 years I am seeing, because the model is very good. The data collection is very faster, and reliable. Real-time data collection is taking place. It is processed very faster in the supercomputer in Delhi, and it is predicting. That is why it is coming. So it is this system I am talking so much because NCR region in northern Delhi, northern India, Delhi around national capital region, air quality prediction is very important. And accordingly, graded action has to be taken. If you predict it and graded action is taken, then your air quality deterioration will be less. You say, this day you have to do these things. And if it is prediction is very good. So this has to be improved now. We have developed a lot, and meteorology play a havoc in the air quality. Same is happening with flooding situation. In the first rainfall, the BOD is getting higher because washing the all urban problems, urban roads and etc. Then rural, all they are washing and telling. After 4 or 5 days, BOD is getting less. Sustained soil is high. But in the month of October, when the rainfall is less, water is available. Your dissolved oxygen is improving. It is going up to January, February. Then water flow is going lesser and lesser. And in the month of May, it is a critical situation. No dilution. Next. Now, one thing is important. The important thing is that whether it is normally distributed, if life is so simple, everything is normally distributed. But God plays the dice. Of course, Albert Einstein didn't believe it in his life. Although he is in the quantum mechanics, it is absolutely probabilistic. God plays the dice. Everything is not exactly the normal distribution. Some are going skewed right side, some are skewed the data left side. Whether it is normal or non-normal, how we calculate? We have to go the measurement of moments. There are 4 moments. Moment means the 4 parameters. One is the central location, that's a mu. First moment, mu1. Second, mu2 is the variance, that is standard deviation square. Third is the same thing, 1 by n with the standard deviation, but it is not square, it is a x cube. That is the third moment. And fourth moment is 4. Next. Now, if it is a skewness, it is a B1, that is mu 3 squared divided by mu 2 3, that is your B1, and kurtosis, measure of flatness, well, whether this flat or steep, that is called kurtosis. It is coming B2, mu 4 by mu 2 square. So this has to be calculated. If the B1 is tends to 0 and B2 is tends to 3, then it is called perfectly normal distribution. Next, I am showing next. Skew is the right side, symmetrical, and skew is the left side. So right side is the mean is here in the tilted, but mean is not exactly the more frequent. Mean is right side actually. That was the problem. Next. That is your, if your kurtosis is like this, if it is a more flat, you are not getting where is the maximum these things. You are steep, then like a kangaroo, 2 kangaroos are there. So whether we'll go for a kangaroos or whether we'll go for a tortoise, that was the question. That is taken by the kurtosis. Next. Now, if it is not normally, you can try with logarithm of the data and go for log normal distribution. But logarithm of the data has lost the sensitivity. Say 10, 100, and 1000, there is a lot of distance in normal situation. But log normal 1, 2, 3. So generally, air pollution data is going with a log normal. And this another distribution is the gamma distribution. There are a lot of distributions are there. Say conductivity. You will find beta 1 is very close to 0.0, 10 to the minus 11, where B2 is 4.54 in normal. And in log normal, it is 0.36 and B2 is 2.24. So you will say conductivity is more or less normal distribution. But in case of alkalinity, it is log normal distribution or gamma distribution. Dissolved oxygen, generally normal distribution. BOD, it is also normal distribution. But BOD can be taken by log normal also. BOD is non-log normal because BOD has a fluctuation. TDS is like conductivity. Fecal coliform, you will find a huge fluctuation in the case of fecal and total coliform. So they are mostly followed log normal distribution. So that is why you have to chase it, which is log normal distribution is a log normal distribution. In case of air pollution, I assure you, particular PM10 and PM2.5 is following log normal distribution. Next. Another thing you are telling, confidence interval, where the true values lies. Get at the certainty, the get at the interval. That means If you go for a 90% 90% confidence interval, your certainty is less because you are rejecting lot of data this side. 1 sigma. Now I am showing is now next say 95%, 99.2.97 into sigma by root over a. 99%, 2.58. 90%. That means only sigma by n. So, and with a 1645, 68% is like this. So more is your confidence interval. You are losing the precision, but reliability of the prediction is right. That means you are taking a lot of data, your range is to plus minus 10. Reliable, your prediction is reliable, but you are losing the precision. Plus minus 3, this precision is there, but you will lose the reliability. You have to choose. Analytical chemistry, it is a very typical example. If you want a more precision, your results will be, you are rejecting the lot of results, or you have to precise the instrument. So atomic absorption, you have generation 1, generation 2, very input the system. Fifth generation, 5G, 3G, kya hai? It is a uncertainty is reliability and precision is coming close. That is the if your generation is more. Otherwise, you telephone, you are not getting the call. Right? You have to wait for a long time. That uncertainty is there. Next. So estimation of mean is like this with 95% confidence interval. You can do like this. It is a 99% confidence interval. Next. You can say, you say 99%, you see that same mean 7.15588 with 95 with 0.3697 bit precise and precision is lost, but the reliability is high. Same is there in BOD, conductivity, coliform, chloride, vehicle coliform, plus minus 1.4983, plus minus 1.7027. So this is the way variance means standard deviation square also calculated like this way. You can estimate mean with confidence interval and variance with means confidence interval. This is a very big chapters actually. In statistics books, general statistics books, it's a 10 to 15 chapters is collecting like this. In the mathematical statistics books, it is a one book for these things. I have taken you in a small because I know you are not a statistician like me. It will be helpful with these lectures. It will be really helpful to you to understand the whole things. I have kept some exercises which you please try. I will try. I have given you your first lecture some exercises, second lecture some exercises, third lecture also here some exercises. You will try the exercises, right? And second lecture exercise is a little bigger, but you try with the calculator. And if you have a problem, particularly I allow you to go for standard deviation with the Excel sheet, right? Because mathematics, if you don't practice, you cannot understand. Once the Alexander came to Aristotle, his guru, sir, I learned these things. What are the easiest methods? But there are three methods only. By practice, and by practice. Thank you very much.